Okay, I'll stop that. We are going to do some polynomial recognition and some basic operations, like ninth grade operations with them. But the main thing I want you to learn at the beginning is whether or not we're dealing with a polynomial, because polynomials are going to exhibit some behaviors as a specific kind of function that we're going to need to know if we're dealing with a polynomial or not. So the first part of your homework tomorrow is going to be whether or not what you're looking at is a polynomial. And so here's some examples. We've got some polynomials on the left-hand side. Polynomials are broken up into things called terms. You can add or subtract these terms together. Whenever you have exponents, your exponents have to be whole numbers. They cannot be negative. They can't be decimals. Your coefficients just have to be real numbers. And of course, the coefficients are just the numbers in front of little things. So here we've got a polynomial. We've got the coefficient of 5. Got an exponent of 2. This has an exponent of 1. There's nothing wrong with that. The second term has a coefficient of 3, negative 3 actually. So we're looking at a polynomial here. It's 4 terms. On the right hand side, these are not polynomials. The reason this one is not a polynomial is because it's got a negative exponent. And here we can never divide by a variable. It's okay to divide by a number, but not by a variable. Alright, so let's take a look at some other things here. Here's some more examples of polynomials. Coefficient of 3, exponent of 1. Here I've got a coefficient that's a fraction. It's okay to have fractions with numbers. You just can't have a variable in a fraction. So these are all examples, and yes, even 1 is a polynomial. And then again, some things that are not a polynomial. You can't divide by an x, can't divide by an x, can't have a negative on an exponent. Here, the square root of x is the same thing as x to the 1/2. So you can't have fractional exponents either. You can do x divided by 2. That's the same thing as 1/2 x. That's a common misconception. You can divide by numbers. That's okay. Again, like 3x over 8 would be the same thing as 3/8 x. The coefficients can be fractions. Square root of 2 is a real number. It's okay. You just can't have the square root of a variable. Okay, again, they're broken up into things called terms, and whenever I refer to the leading term, you're going to want to look at the term of highest degree. That means which term has the biggest exponent on it. The 4 is called the leading coefficient. And the last number that typically has an x to the 0 on it, and we hide that because anything to the 0 is a 1, the last term is called the constant term. Alright, polynomials are named by their degree. So the degree is what's the highest exponent you see. We have been working with quadratics with factoring. If you have a polynomial that has a degree of 2, the highest degree is 2, we're going to call that a quadratic. If a polynomial's highest degree is 3, that's called a cubic. And if a polynomial's highest degree is 4, that's a quartic. And if the highest degree is 5, that's called a quintic. Other polynomials that are bigger than this also have names, but I've never used them before, so I don't even know what they are. You are going to add and subtract things together, so put on your little 7th grade thinking hat and think about like terms. When you're adding and subtracting, you can only bring things together that look exactly alike. You could not add 4x and 3 together, for example, or 4x and 3y, or 4x and 3x squared. But you could add 4x and 3x together because those little variables match and play the little matchy-matchy game. Okay. So let's take a look at a couple of examples. Give the degree of the following polynomial. I've got 2x to the 5th minus 5x cubed minus 10x plus 9. You are going to look at all the exponents, and you are going to look at the biggest number you see. The biggest number you see here is a 5. This is a 5th degree or quintic polynomial. Alright, let's do some simplification. This is like term practice. Really, really hard. Let's take a look at all of our x cubes and add those together. I have a 10x cubed and a minus 4x cubed, so that's 6x cubed. Mark those off since I've already done them. And then I've got nothing else with the x squared, so that just stays negative 14x squared. And I've got 3x and 4x adds together to be plus 7x, and then of course minus 6 will be my constant term at the end. What's the degree of this polynomial? What's the degree? It's a 3rd degree polynomial. And the leading coefficient is a 6. Alright, let's subtract some. When we have a minus sign in front of a polynomial, please don't forget to distribute it. So this is, I'm going to go ahead and distribute that negative sign. This is 25 minus x minus 3 and then plus x squared. And then let's bring together the 25 and the 3, and I'll write it in what's called descending order. In other words, I'm going to write the biggest power first. X squared minus x and then plus 22. So quadratic. Okay, now this is the thing that some people actually mess up on. It's shocking to me, but they don't know how to FOIL or box or whatever. X plus 3 times x plus 2 is not x squared plus 6, although for some reason I can't get rid of that notion. That's not the correct answer. You have to FOIL it, double distribute, however you learn to do this in algebra. I'm going to line these up like I was multiplying a 2-digit by 2-digit. And this will be 3 times 2 is 6. 2 times x is 2x. And I'm going to leave a space. X times 3 is 3x. And x times x is x squared. And then I'm just going to add them up, just like I'm doing 2-digit by 2-digit. So I've got 6, I've got 5x, and I've got x squared. And all you have to do is put, the sign in front, whether it's positive or negative. That is the correct answer for x plus 3 times x plus 2. Alright, last example. This could get messy unless I line these up, so I'm going to line these up vertically. And since we have the commutative property of multiplication, that means that order doesn't matter. I'm going to put the longest polynomial, which is the 3rd degree polynomial, on top. And then I'm going to put the binomial on bottom, and I'm going to line them up like this, and I'm going to multiply them just like I was doing at 1, 2, 3, 4 digit by 2 digit. So let's see if we can't get this right here. Negative 17 times 2 is negative 34. 2 times 4x is 8x. 2 times 3x squared is 6x squared. That 8x is positive. 2 times x cubed is 2x cubed, and that 6x squared was also positive. I'm going to leave a space, and then I'm going to go through here and multiply with all the x's. X times 17, and that's a negative 17, is negative 17x, and then plus 4x squared, and then plus 3x cubed, and then plus x to the 4th. Line it up, and then I've got x to the 4th plus 5x cubed plus 10x squared, and then what is that? Minus 9x, and then minus 34. Okay, so anyways, that's just make sure you distribute correctly, or you can go through and just do a bunch of these things, or if you line them up vertically if you want. But tomorrow in class, all you're going to have to do is you're going to multiply, you're going to add and subtract, and you're also going to identify whether or not something is a polynomial. It should be straightforward and really, really easy. I'll see you then.